Welcome to the last part of chemical formulae and equations. So this video is going to be very short because we're just going to take a look at a very short subtopic. So in the previous videos, we looked at chemical formulas, state symbols, chemical equations, and this is where we ended. In this video, we're going to take a look at ionic equations. So what are ionic equations? Ionic equations show only the ions involved in a chemical reaction. So whenever there is a reaction, ionic equations are only concerned with ions that are involved in the reaction. Ions that do not take part in the reaction, which are called spectator ions, are cancelled out in the construction of ionic equations. So ions that do not take part are said spectator ions, like they're just spectators, just spectating the reaction. They don't participate in the reaction. So here are the steps to consider when writing the ionic equation. The first is construct a balanced chemical equation. We learned how to do this. Second, split only soluble ionic compounds into ions. Insoluble ionic compounds, elements, and covalent compounds remain unchanged. So what you concentrate on are ionic compounds that are soluble. And how do you tell that they are soluble? You're going to see the aqueous, showing that they are in the aqueous state, or they are in the aqueous solution. So whenever you see a compound and there's the AQ at the end, just know that that is an ionic compound, and you can split it into the individual ions that makes up that compound. Finally, cancel out spectator ions. So these are ions that appear on both left and right hand side of the equation. So spectator ions, which are ions that do not take part in the reaction, you're going to find them on the left and on the right side of the equation. So you cancel them out, and what you're going to remain is a balanced ionic equation. Let's take a look at an example or two. So here's an example. So barium nitrate reacts with sodium sulfate to form barium sulfate and sodium nitrate. So how do you deal with this one? So the first is to make sure that the equation is balanced. So if we look at this, we have one barium here. We have one barium. Nitrogen, how many nitrogen do we have here? So we have two nitrogens. We use this because we don't have any number here. So nitrogen, we have two here. This two is for all the atoms or elements that are inside. So N is two is for nitrogen and also for oxygen. Therefore, we have two nitrogens here. Then if we go this side, we have two nitrogens here. When we go to oxygen, there are three here. So 3 times 2, you multiply them because of the brackets, they are going to be 6 plus we have 4 oxygen also here. So 6 plus 4 is going to be 10. How many oxygens do we have here? Here we have 4. Then here we have 3. And here there's 2 here. So 2 times 3, it's going to give us 6. So I've got 6 oxygens here. So this 6 oxygen added to this 4 oxygen here, we get 10 oxygens. So oxygens are balanced. We go to sodium. Sodium, we have 2 sodiums here. And this side, how many sodium? 2. So balanced. Sulfur, S. How many sulfur do we have here? We have 1. There is no any number here or here. So sulfur, it's only 1. And when you go here, sulfur is 1. So this is balanced. Once it's balanced, you break ionic compounds that are soluble. You break them into their individual ions. So how do you tell that it's soluble? So like I explained, you tell solubility by this. So the AQ shows that this is a substance that is dissolved in water. So we're going to break this into its ions and this into ions. And also here we have this, which should be broken into its ions. With that being said, the other question is, how do we come up with the ions that makes up this? So use valences. The ion for the ion that is going to come from this barium is derived from, or it can be written as barium with the valency on top, which is going to represent the charge. So the valence of this atom or element, if I put it in that way, is going to give you the charge of the ion that is in here. So barium, what is the valency for barium? So barium is just an element that you are not expected to master. So you can go on the periodic table and you're going to discover that it is in group 2. Therefore, barium has a valence of 2, and its time is going to be barium with a positive 2 on top. Why positive 2? Because it's a metal, and when you have a compound, anything that is on your left has a charge of positive 2. Mean that it is a metal. Then what about nitrate? So nitrate, if you go back to the table of radicals, this one has a valence of 1. Therefore, its charge is going to be -1. Why? Because it's a non-metal, so it's -1. Also, ions that are on the right hand side, you can create a system where you should always remind yourself that these ions that are on the right hand side, they have a charge of a negative. So once you identify the values that it is 1, then the charge is -1. So that's how this is going to break. So if we go to this one also, sodium, we know it's in group 1, so it's going to have a charge of 1, +1, since it's a metal. And sulfate has a charge, has a valence of 2. Therefore, this one is going to be -2. Then when we go here, this is in solid, we don't touch it. We go here, we've got sodium. So sodium already we have identified for me that the valency is 1, and therefore the charge is +1. And the nitrate we have identified that it is also 1, and since it is on the right, like on this compound, it is on the right and sodium is on the left, so it is a non-metal, and therefore it has a charge of -1. So what I'm saying is we're going to have this barium with +2 charge in aqueous solution, nitrate with -1 charge. So now here is one thing to be careful about. So when you look at nitrate here, how many nitrates are here? There are 2 nitrate radicals. Therefore, when you break barium nitrate into its constituent ions, make sure that the 2, you put it in front of nitrate. So it's going to be 2 nitrate -1. So the same is true for sodium. There are 2 sodium atoms here, so the 2 is going to be in front of the sodium ion. Sulfate, it's only 1 here. This 4 is just for oxygen, and the radical is written as SO4. So this 4 has no bearing. So there's only 1 sulfate here. So it's just sulfate with a charge of -2. When you go here, this one, we do not touch it. When you go here, sodium 2. So it's we're going to just write it 2 sodium +1 ion plus nitrate. Nitrate is 2 also. This 2 here belongs to sodium and nitrate. So we're going to have 2 nitrate with a charge of -1. We go to the next step. The next step is to cancel out spectator ions. Spectator ions are those ions which do not take part in this reaction, which are just spectating the reaction. So how do we identify? If there is an ion here and there is also an ion here, then they are spectators. They have to be cancelled. So we start with barium. Can we find barium on the other side of the equation? There is no barium here. So this is not barium, this is barium sulfate. We want this barium ion. So barium is not present here. What about nitrate? Nitrate, here it is, but here, yes, we have nitrate here. If you look carefully, there are 2 nitrate ions here, and here there are 2 nitrate ions. So these are spectators. We have to cancel them out. So this is going to go, this is going to go. We go to sodium. Sodium, there are 2 sodium ions here, and we go here, there are 2 sodium ions. So these have to be cancelled. So this will go and this will go. What about sulfate? Sulfate, we have 1 sulfate here. Do we have another sulfate here? If we look, there is no sulfate. This sulfate which is here is not an ion. It's part of the compound here, and it is in solid. So we only look for the ions which we have separated. So now that we have cancelled the spectator ions, we rewrite this without spectator ions as the final step. So I've got barium, which is reacting with sulfate, produce barium sulfate. So this is the balanced ionic equation of this reaction. Let's take a quick look at the last sample. So we have this copper carbonate plus hydrochloric acid, which produces copper chloride plus water plus carbon dioxide. So the first thing is aqueous, the substances that are in aqueous solution, we separate them into their individual ions. So we have this one, which is hydrochloric acid. We also have this one, which is copper chloride. So when we do that, then we're going to cancel out spectator ions. So this is an example. So we're going to have this. So we have just separated hydrogen, it has become 2 hydrogen. Chlorine, it has become 2 chlorine. This 2 is for both hydrogen and chlorine. So forget about the cancelling, I'm going to explain. Then when we go the other side, we have copper chloride. So this is in aqueous solution. So we're going to have copper and chlorine. The variance of copper, here, how do you tell that whether it's copper 1 or copper 2? So just from the number here 2, it means this 2, when this compound was being formed, if you remember when coming up with chemical formulas, this 2 belongs here, meaning that the 2 is the valence for this element, and for chlorine, the 1 is the valence for chlorine. So copper chloride will have 2 plus as the valence, and chlorine is going to have minus as the valency. But for chlorine, there are 2 chlorine atoms here, so even when coming up with the ions, they're supposed to be 2. These 2 will be in front of chlorine, and it becomes like this. Water, nothing changes. Carbon dioxide, nothing changes. So what is common? We look at the ions. Hydrogen, it's here. There are 2 hydrogens here. Here, there's no hydrogen ion. Then we go to chlorine. There are 2 chlorine ions here, and here there are 2 chlorine ions, so they are going to cancel. That's all. So the final balanced chemical equation, the final balanced ionic equation is going to be this. So I've just removed the spectator ions. And note that the first step, always you should make sure that your equation is balanced, but I did not do that. Yeah, I didn't want us to spend a lot of time here, but this equation was already balanced. So if you have free time, you can just take a look at it and you're going to realize that it is already balanced. So this is a balanced ionic equation for this reaction. This marks the end of this part. Happy solving.